Guys, this is Miss Jackson back with your notes for today. We are working on properties of operations. This will be our last set of notes in our rational numbers unit as we move on to the study guide and working on our unit test for rational numbers. So we will go ahead and get started. First things first, by using properties, we can organize the problem to be less complex. So properties are meant to help you rearrange your problem, work your problem, however you need to make it less complex for you. All right, so the first property we're going to talk about is commutative property of addition and multiplication. Most properties we are talking about today are going to be for addition and multiplication. So just keep that in mind as you are working. So with the variables, we are seeing that we can add p plus r is the same thing as r plus p. And same thing when we multiply. P times r and r times p are equal to each other. So the commutative property has to do with order. You can change the order that you are adding or multiplying without changing your solution. So we are going to prove it with rational numbers, and I'm going to say that p is going to be equal to -3, and r is going to be equal to -5. And you can pick whatever numbers that you would like to pick, but these are the ones that I'm going to do. And I'm going to say addition over here, multiplication over here. All right, so when we go to make those substitutions, we are going to be taking out the variable, putting in our numbers. I'm going to say -3 plus -5. And if I work this out correctly, it should be equal to -5 plus -3. Okay, I have two negative numbers, and so I'm adding them. That means that I just add them up. So 3 plus 5 is 8. And since they're both negative, I keep my sign. Same thing for the right side of the problem. I have two negatives, so I add 5 plus 3 is 8, and I keep my sign. So this one does check out the commutative property. All right, let's look at it for multiplication. -3 times -5 is equal to -5 times -3. All right, and I multiply, and then same sign, positive answer, opposite signs, negative answer. So I multiply 3 times 5 is 15, and it is same sign, so it's positive. And then I go to the right side of the problem, 5 times 3 is 15. Again, they have the same sign, so it is positive. So that is just showing you an example of how to prove that the commutative property works for both addition and multiplication. All right, our next property is the associative property of addition and multiplication. This one has to do with your grouping. It is how you group numbers to work the problem. So if it helps you to group a set of numbers together, that's where you're going to want to use your associative property. I am going to substitute -3 again for p, -5 for r, and then we have s, which I'm going to use +2. Okay, I am going to set mine up again for addition and multiplication. And again, we're just proving that it doesn't matter what you group together when it's all addition or all multiplication, that you will still get the same answer. So the first one, we have -3 plus -5 grouped together, and then we're going to add in +2. And then I'll have to move my line over, which is not a big deal. We want to set that equal to -3 on the outside plus -5 plus +2. All right, so -3 plus -5 is -8, and -8 plus 2 is -6. Since we have to subtract 8 minus 2 is 6, take the number with the greater absolute value. Equal sign. This one has me adding a positive and a negative together first. So -5 plus 3 is going to be +5. 3. I'm sorry, not positive 3. Negative 3. And negative 3 plus negative 3 is negative 6. I like this property, the associative property, because to me, when I group all my negatives together, it's easier than when I have to remember, okay, which do I add or do I subtract? My negatives to me are easier to add up, my positives second. All right, let's look at it for multiplication. We're still going to be using negative 3, negative 5, and positive 2. So I have negative 3 times negative 5 times 2. And I'm going to set that equal to negative 3 times, I'm running out of room, negative 5 times 2. Okay, a negative times a negative is a positive, so I have positive 15 times 2, which is 30. And then on the other side, I have a negative times a positive, so that is negative. So I have negative 3 times 10, negative 10. And then negative 3 times negative 10 is positive 30. I am not sure what happened here, friends. That should be a 30. I think I said 30, and I wrote down 15. Okay, again, 30 equals 30, so either way that you do it works in this situation. Again, I like to group my negatives together and take care of those first. To me, it's just easier. All right, moving on to the distributive property. And again, most of you have seen the distributive property before. You may not understand it. I like to think of the distributive property that you are distributing. So you are giving away whatever's on the outside of the parentheses to every number that's on the inside. So we are giving via multiplication. Okay, so I like to think about Santa Claus here because Santa Claus distributes all of his gifts to everybody. So that's what it makes me think of. We will still be using the same negative 3, negative 5, positive 2. All right, then I'm going to set line up. Negative 3 on the outside. I have negative 5 plus positive 2. Okay, and again, we are distributing. So when I distribute, I'm going to multiply negative 3 times negative 5. And then I want to multiply negative 3 times positive 2. All right, and the number that, or I'm sorry, the symbol that goes right here in between my two sets of multiplication is going to be whatever symbol is inside the parentheses. So we will be adding those up. All right, negative 3 times negative 5 is positive 15. And then we have negative 3 times 2 is negative 6. And then 15 plus negative 6 is going to be 9, positive 9. If I were to, and I'm going to try and erase this without erasing my problem. If I were to go back to my original problem right here and solve it without distributing, we should get the same answer. Negative 5 plus 2 is positive 3. And positive, I'm sorry, I don't know why I keep saying that. It is negative 3. Negative 3 times negative 3 is positive 9, and those do equal each other. So sometimes it makes it easier to distribute the number on the outside. Sometimes it's easier to do the math inside the parentheses. But when you distribute, you need to make sure that you are distributing that number on the outside to both numbers inside the parentheses. All right, we have our multiplicative inverse. Okay, multiplying by the inverse. If I have P equals negative 3, I'm going to get off the lime green. P equals negative 3. I set this up as negative 3 times 1 over negative 3. and that'll equal 1. Okay. And just showing you how this works. When we have a whole number, it's always over 1. -3 times 1 is -3. On the bottom, -3 times 1 is -3. A negative divided by a negative is a positive. Okay, so 1 equals 1. That is the same thing if we're going to change from division and do keep change flip to change from division to multiplication. So your multiplicative inverse. That's just another way to get rid of a fraction so that you don't have to worry about fractions in a problem if there's only one or if they don't, or if they're pretty big numbers, things like that. So that's just helping you make it not as complex. All right, we also have our additive inverse. This is going to be your, I'm going to go up here and keep change flip. That's going to help the multiplicative inverse where you can multiply by the inverse of that number. Additive inverse is going to be your keep change when you change from subtraction to addition. Okay, we're going to use our same numbers. P is -3 and R is -5. So I'm -3 minus -5. And that is going to be the same thing as keep it, change it to addition, change the negative to a positive. Okay. We have here, this is +2, and that is equal to +2 as well. All right, so that is your definitions and examples, and we are going to work a couple of examples on the next page. If there is a point where you cannot find a division sign or anything, feel free especially for these fraction problems, to use the slash. That's the same thing. Use your understanding of the properties of operations to make the problems below less complex. All right, so number 1, 8 4/10 divided by 1/5 times -2. First thing that strikes me in this problem is the fact that we have one fraction, one decimal, one integer. I want to go ahead and get rid of that fraction, so I am going to do keep change flip, and that's going to allow me to change it to multiplication number 1 and then to get rid of that fraction. And that again is part of that multiplicative inverse. 8 4/10. I'm going to change it to multiplication, and I am going to flip to 5/1 times -2. We do know that 5/1 is the same thing as 5, so I can rewrite this to say, so not only have I changed the division to multiplication, but I've also gotten rid of my fraction and changed it to a whole number. So I can go ahead and multiply. And in this case, I would multiply my two numbers first and then multiply my decimal second. So I do know that I am able to do that per the associative property. And if you need to go back and look at that definition, feel free. 5 times -2 would be -10. And then anytime you multiply by 10, 100, or 1,000, that's just moving your decimal place one place out per every 0. So 10 only has 1 0, so we move our decimal place one place. 8.4 times -10 is going to be -84. It says, how did you use the properties of operations? Well, we use the multiplicative property, multiplicative inverse property. I'm just going to write that down. We'll use that to get rid of the fraction. And that was the main property. All right, let's go ahead and look at number 2. I'm negative 11.7 plus 6.5 plus positive 11.7. What I notice here is that I have opposites. So I can go ahead and use my commutative property of addition to rewrite this problem to put my opposites together so that I can say, well, negative 11.7 and positive 11.7 go ahead and cancel out because they are additive inverses, and additive inverses add up to be 0. And then I'm left with 6.5 as my answer. Okay, and again, that property that we used right there was the commutative property, so we could add our opposites. And again, opposites always will add up to be 0. All right, I have some fractions and a whole number. Thankfully, the fractions that I'm adding do have common denominators, so that is a plus. I am going to use my commutative property here so I can rewrite them to be next to each other and then add my whole number on the backside. So 2/3 plus 1/3 is 3/3, and 3 plus 1 is 4. So I have 4 and 3/3 plus 8. 4 and 3/3 is going to be the same thing as 5, and 5 plus 8 is going to be positive 13. Okay, and again, we used our commutative property. All right, let's scroll on down to examples 4, 5, and 6. And again, at any point you need to stop the video, you want to work these out on your own, please feel free, and then jump back on and make sure that you check your work. Okay, looks like on number 4, we have some distributing that we can do. We can distribute the -3 to the 2 and the -3 to the fraction. So we have -3 times 2 plus -3 times 2/3. All right, -3 times 2 is going to be -6. And this right here, the -3 times 2/3, that is going to be part of your multiplicative inverse. And I'm going to scroll up and show you that these canceled out and it just left you with whatever number is on top. And that's the same thing that's going to happen here. Oh, not too far. Our 3's are going to cancel out and we're going to be left with whatever's up here. Okay, and don't forget to bring that negative. So I'm left with -6 plus -2, which is -8. And again, I use my distributive property. And my multiplicative property. Make sure I'm spelling that right. Okay, and we use that multiplicative inverse to get rid of the fractions. Okay, -1 times -1 times -2.6 times 1. Okay, I'm going to use my commutative property to rearrange all of my 1's. Okay, so I can go ahead and get those taken care of. -1 times -1 is +1, and +1 times +1 is 1. And then I just have 1 times -2.6. Anytime we multiply by 1, we always get the same number. they have opposite signs, so my answer is going to be negative. And again, I use my commutative property, so I could change the order without changing my answer. All right, then last but not least, I have 2/3 plus 4/9 plus 7/9. I want to use my associative property on this problem because I want to group my two fractions. I have common denominators first, and then I can add all my 2/3. So that's what I'm going to do. 2/3 plus parentheses 4/9 plus 7/9, because I want to do this first because they have common denominators. 2/3, 4 plus 7 is 11/9. Okay, now next step is common denominators, and that would be 9. So multiply by 3, multiply by 3. I'm now at 6/9 plus 11/9. 6 plus 11 is 17, and I have 17/9, which is the same thing as 1 and 8. Oh, that looked ugly. 8/9. Okay. So again, either answer is correct. Obviously, the most correct here is going to be the most simplified. The only thing we did here was we used our associative property, where we changed what numbers were being grouped. Our associative property. Okay, I'm going to zoom out just a little bit and talk about homework. On questions 1 and 2, they are multiple choice. Question 3, you are taking your original expression, doing whatever property it's telling you in the property column, and then you're going to write your equivalent expression. So on this first one, it is saying that it is 4 parentheses 5 plus 7, and it wants you to distribute. So we would write 4 times 5 plus 4 times 7. And that is going to be 20 plus 28. And that is the same thing as 48. Okay. And then on 4 and 5, it is just asking you to describe the benefits of using that property. All right, guys, make sure you have finished your notes. You have done the homework before you click submit. And then make sure that you are actually turning in the assignment on time to get credit for being in class. As always, questions, comments, concerns, make sure that you are letting me know. And then I will check in with y'all in a little bit.